I don't know about you, but I like money. And I like it when my money works for me. In other words, I'm going to invest my money, and I want my money to make money. You see? Now, here's the interesting thing. Do you realize that investing money is actually an exponential function? Yeah, it is. Does this formula look at all familiar to you? It's exactly the exponential function formula, but there's a couple of extra little things in it. And the extra little things in it are something called the compounding periods. Whoa, 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 whoa. Let's slow down for a second. Let's take a look at this up close. Well, AT, of course, means your total. That's your final investment. That's how much you're going to get, right? This is called A naught. That's your initial investment. How much do you actually put in? Now, interest is what your investment's going to make. That's how it makes money. So the interest is usually right here. Now, they usually give that interest rate in percent. So make sure that you don't put it in percent. You convert that into a decimal. Now, time, that's easy. How long are you going to invest it for? You're going to invest it for a month. You're going to invest it for 2 years. You're going to invest it for 30 years. Here's the thing, and here's a little bit of a tip for investments. The longer you put it in, the more money you make. Okay, so we'll talk about that again as we go along. So what is with this thing called the N? The N refers to the compounding periods. That's something that we're going to discuss a lot down here. Okay, compounding periods is how is your interest accumulated. Okay, so let's talk a little bit more about some general stuff, and then we'll get into the nitty-gritty. So when money is invested in a savings account, it earns interest. No kidding, right? But if the account remains untouched, that means you don't take any of the money out, and that's the hardest part. When you look at your savings account and you see money, you have this tendency of wanting to spend it, right? That's the thing that's going to kick you in the head, unfortunately, right? You got to leave your money there, right? It's going to make more money for you as it goes. But if you don't take any of the money out, the interest is reinvested, and it makes, guess what? Not just the original amount that you invest, but now the interest makes interest because you're reinvesting it. So this is known as compound interest. That's that old snowball effect. You've heard of this before, where you get the little snowball here, and as you're going down here, the snowball gets bigger and bigger and bigger. Well, exactly. That's how compound interest works, because whatever you're making, you're putting it back into your account and you're reinvesting it and making interest on the interest. Okay. With that said, let's talk about a few things here. I'm just going to write down the formula again. If you remember, your total interest or the total amount made is your initial amount that you invest, 1 plus your interest rate over how many times it's compounded, times N, the number of times it's compounded, times the time that you invested for. Now, let's talk about a few different interest rates. One is called annually. The annual interest rate is kind of like what a GIC would be and GIC stands for a guaranteed income certificate. This is some of the investments that people do in banks and stuff like that. Canada savings bonds are usually done this way. Okay, so GICs, what happens? You invest the money, you'll leave it there for a whole year, and then at the end of the year, they give you interest and your money back. Sounds pretty safe, doesn't it? Yeah, it's one of the safest investments you can make. Now, look at the formula. Think about this. If we're doing this once a year, the compounding periods is 1. That means your N equals to 1. Look how this changes things. This is really cool how this changes things. If your N is going to equal to 1, that means this N equals to 1, which means if you think about it, this will be 1 plus your interest rate times T. That's what we got written down here. Because you're compounding only once a year. If you invest for 2 years, great. 2 times 1 is still 2. Invest for 5 years, 5 times 1 is still 5. So this is how this formula gets interpreted. But again, it's from our original formula. Let's look at another type of interest rate. An interest rate compounded semi-annually, which means twice a year. That's what semi-annual means. Most of the time, you're looking at mortgages at this one. Mortgages, they only allow, in Canada specifically, only allow interest to be accumulated twice a year, which I think is pretty interesting. So the number of compounding periods is 2 then. So your N equals to 2. Now, what does this mean? Look at your original interest rate right here. Do you remember this little section in here? Right? Let me rewrite it for you. 1 plus I over N. But this is going to be N times T. Aha. So T still is in years. Okay? N now is 2, which means, think about it. If you make, let's say, a 10% interest rate compounded semi-annually, what are you making each time? You're making 5% on the first part of your investment, and then the next time you're making 5% again for a total of 10%. You're not making 10% in 6 months, and another 6 months later you're making 10%. That would be a 20% interest rate. That's crazy. Okay? It's 10% for the first, or I should say it's 5% for the first, 5% for the second, for a total of 10. That's why we have to divide it by the compounding periods. Okay? Which also means then how many years you're going to invest this in. If you invest it for 1 year, guess what? Because the compounding interest rate is semi-annual, it's 2 times whatever the time is. I know you're getting confused. Watch down here. Look, initial investment, there's your compounding periods. That's all you got to do is take that 2 and put it in there. Look at the next one. Next one is quarterly. Quarterly, some stocks work this way. If you get a stock portfolio, sometimes they go quarterly. Every quarter, they give you a note saying this is how much money you're making. Okay, so interest rate is made 4 times a year. So guess what? You're compounding 4 times a year. So guess what? That becomes 4. Yep, and that becomes 4. You see how it works? Pretty easy. Okay, let's go on to this one. This monthly, this is the killer. Monthly would be something like your loans and your credit card payments. Okay, if you take out a loan from the bank, you're going to be paying monthly. If you're taking out a credit card, you're going to be paying monthly. And that expense could be pretty nasty because then your interest rate is made every month for 12 times a year. So you look at this, your N works out to be 12. Oh my gotcha. So sure, you divide the interest rate by 12, but you also multiply the compounding rates by 12, and that's what gets you. That's one of the reasons why credit cards like this so much, because this is a chance for them to make the most amount of money. But what if you're charged a daily interest? What are you, a loan shark? Oh my goodness, a daily interest would mean 365 compounding periods, and 365 times T being how many years you invested in. So if you think about it, what you got to work out on this is this. The essential part is this. This is your growth factor. Now, I put down the domain is not continuous because, of course, it's not for every second of every day. It's either once a year, twice a year, 4 times a year, right? 12 times a year. So it's not continuous, right? I does not represent the annual interest rate either. Okay? I is not always represented the annual interest rate because we got to make sure we divide it by N. And N does not represent the number of years that you're investing. N is how many compounding cycles you have. Oh boy, this is confusing. Well, I hope not to confuse you by looking at this chart. Okay? I'm going to give you a wonderful example. We're just going to compare putting $1,000 in, how this works. I think it'll be really, really cool. Stay tuned. We'll put this in to another podcast.